Should you believe a statistical study? When you start hearing commercials or politicians or corporations talk about things in percentages or averages and that type of thing, you tend to want to believe it, right? But they're either not necessarily true or sound true and aren't. So today we're going to look at some ways you can identify if the study may not be completely measuring what it's talking about, okay? Most statistical research is carried out with integrity and care. Nevertheless, statistical research is sufficiently complex that bias can arise in many different ways. There are 8 guidelines that can help you answer the question, should I believe a statistical study? So guideline 1 says get a big picture view of the study. Answer these questions. What was the goal? What was the population and was it clearly defined? And what type of study was used? Was it the correct kind of study? Consider the source. Statistical studies are supposed to be subjective, but the people who carry them out and fund them might be biased, okay? If you are a toothpaste company and you are measuring the whiteness of your toothpaste, then you might be biased if the toothpaste company itself is doing that study. But if they got somebody outside to do it, then it might be more accurate. Look for bias in the sample. Selection bias happens whenever researchers select their sample in a way that tends to make it unrepresentative of the population. Toothpaste company could go out and select people that already got white teeth, right? Participation bias occurs primarily with surveys and polls and arises whenever people choose whether to participate. So a participation bias could be like doing a survey on people where they're listening to the radio and they have to call in. Okay, so are the people that listen to radio really representative of the population? It might be, but it might not be. If you're trying to include young people in that sample, then most of them listen to Spotify and stuff like that, right? Not the radio. So you have to think about what participation is happening in your study. Look for problems in defining or measuring the variables of interest. A variable is any item or quantity that can vary or take on different values. And the variables of interest are the items or quantities that the study seeks to measure. To make sure they're clearly defined. Example 1 says, a commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10 to 20% of the illegal drugs entering the United States. What do you think? Does that sound believable? Why not? I mean, it sounds like something you would hear, right? Think about why it might not be believable. There's 2 variables here. There's the quantity of drugs that are intercepted, and there's the quantity that is not intercepted. Well, we can definitely measure the amount of drugs that are caught, right? Can you measure the ones that aren't caught? How do you know? right? The number not intercepted is impossible to measure. Your book says, in a New York Times analysis, a police officer was quoted as saying, "This is the kind of statistics that is a PFA, pulled from the air. It is not based on anything." Beware of confounding variables. So variables that are not intended to be part of the study, that are kind of stuck in there, may make it difficult to interpret, or might confound it, make it confusing. Confound and confusing, kind of the same thing. Consider the setting and wording in the surveys. Even when a study is conducted with proper sampling and clearly defined terms and questions, it is important to watch out for problems in the setting or wording that might produce inaccurate or dishonest responses. For example, the Republican National Committee commissioned a poll to find out whether Americans supported the proposed tax cuts. Asked, "Do you favor a tax cut?" A large majority answered yes. Should we conclude that Americans supported the proposal? So, if somebody were to just walk up to you and say, "Would you like to not pay taxes or pay less?" Well, duh, yeah. But if there's a tax cut, there's repercussions to that, right? So when the study is conducted, you need to know what those repercussions are, or you need to know if there's other options, okay? So this question is biased because it does not give any other explanation or options. What if they were to ask, would you favor a tax cut even if it increased the federal deficit? Your answer might be a little bit different there if you don't want the federal deficit to go up. Or would you support a tax cut if we cut out Medicaid or something like that, okay? So it just depends. It really depends on what is what they're really measuring here. So guideline 7 says, check the results are presented fairly. So the study may be misrepresented in graphs or concluding statements. And we'll look more about graphs in the near future. Researchers may misinterpret the results or jump to conclusions not supported by the results. The school board, I like this one, in Boulder, Colorado, created a hubbub. A hubbub, if you don't know what that means, like a ruckus or a bunch of angry or upset people, when it announced that 28% of Boulder school children were reading below grade level, and hence concluded that the methods of teaching reading needed to be changed. This happens all the time. 28% below grade level. Does that sound good or bad? The announcement was based on reading tests on which 28% of Boulder school children scored below the national average for their grade. Does this data support the board's conclusion? Grade level is equivalent to national average in this study. Okay? So what's the national average? The national average would mean that you've got an average, okay? There's a middle number. And 50% of the nation is going to read above that average and 50% below, right? So below grade level would refer to half or 50% of the nation's students. So if 50% of the nation reads below grade level, but only 28% of Boulder's population students read below grade level, wouldn't that be a good thing? Okay, they're better than the national average. So this statistic, though it sounds good, is not a justification at all for changing teaching methods. This happens. Sometimes there's no justification at all, and they just say, oh, we're going to change it, see what happens. Yeah. And Guideline 8 says, stand back and consider the conclusions. Ask yourself the following questions. Did the study achieve its goals? Do the conclusions make sense? Can you rule out alternative explanations for the results? And if the conclusions do make sense, do they have any practical significance? Are they important? An experiment is conducted in which the weight losses of people who try a new fast diet supplement are compared to the weight losses of a control group of people who try to lose weight in other ways. After 8 weeks, the results showed that the treatment group, the people that took the supplement, lost an average of half a pound more than the control group. Assuming it has no dangerous side effects and they did everything to plan, does this study suggest that the supplement is a good treatment for people wanting to lose weight? Well, it turned out that the people that took the supplement lost more weight, right? But how much more? A half a pound. Okay? Is that enough to make any difference? So, half a pound is hardly measurable. Even if the study is flawless. There is no real practical significance. Because half a pound really doesn't mean anything. Now, if you wanted to lose weight an easy way by taking the pill instead of working out or eating right, then it might be worth it to you. But if you're willing to do it a more healthy way, then not going to be worth it, right? Okay, so that section was pretty short.